The next solid state component that we're going to talk about is the transistors. Transistors can work as switches, or they can amplify by controlling or metering the amount of current that they conduct. Transistors have these three elements: emitter, base, and collector. And there are two basic types of transistors, either NPN or PNP. Both of them will look the same and will have the same three legs. A good way to remember them is that this one over here, the NPN, you can say that it's not pointing in, but the PNP is pointing in. And what they're talking about is when you draw a symbol for an NPN, you look at this arrow and you say that this arrow is not pointing in to this base, but the PNP, the arrow is pointing in. And that's how you remember that. The emitter will always be the one that is on the arrow. This is a not pointing in, but even if it was the not PNP where the arrow was pointing in, still that would be the emitter. The base always goes to the middle, and the collector, it is the one that does not have the arrow. When you are given a transistor, you're going to have to look at the data sheet to be able to tell which leg is actually the base, the collector, and the emitter. Since the arrow is pointing out, I have to make sure that I connect the negative on the bottom side so that when electrons try to flow, will flow against the arrow, because you could think about this as the same principle for diodes, that current flow against the arrow. So I connected here the battery, the negative side, and the positive side, I hook it up to the collector. Now, in this case, the light will not be working. At least not yet. Now, following the same principle, I still hook up a negative of this battery to the base and the emitter, and then a positive of a different battery to the base. What's going to happen is that if I allow a little bit of current flow, because I put a resistance over here, as electrons start flowing this way, the transistors get biased, and then there is going to be a large current flow through this way, and the light is going to come on. If I reduce the resistance, that means it's going to be a larger amount of current flow here, and there is going to be a proportional higher amount of current flow between the emitter and the collector, and the light is going to go brighter. If I remove the resistance altogether, well, I'm still going to have a little bit of resistance, but not much. I can increase the current flow over here, and a much larger current flow will go through here, the light becoming very, very bright. So with a little bit of current in here, and I'm just going to make a small eye, I'm controlling a very large amount of current over here. So yes, you can say that I'm using the transistor as an amplifier. And that's one of the main things that transistors do. If I want to use a PNP transistor for this demonstration, now the arrow will be pointing in. If that's the case, I have to reverse the polarity of both of my batteries. So I'm going to do that right now. Now that I have reversed my polarities, now my negatives are on top. So electrons will be able to flow both between the collector and the emitter, and the base and the emitter. They are going to be able to go against the arrow, and that's exactly what we want. That is what's called a forward bias. Even though I just gave you this word, make sure you remember that, because transistors and diodes, they will only work when they are properly biased. if you need to take something away from this training, is that in transistors, the current between the base and the emitter controls a larger current between the emitter and the collector, and that's how amplification takes place. Here we have a basic transistor amplifier where we come in with very small millivolt signals, less than 1 volt, and here we can amplify the signal from 0 volts all the way up to 10 volts. That is what we call amplification. They got a whole bunch of resistors that this one's for proper bias, and they got different kinds of bias or ways to make sure that they can control the controlling current, which is between the emitter and the base, so that they can control or they get as an output the larger current, which is between the emitter and the collector. Transistors are highly known for amplifying current, not so much voltage. It is important to have the right polarities on the transistors, and then to get the right amount of current going between the base, or rather from the emitter to the base in this case, because this is an NPN, and that's called the current that goes from here to here is what's called the bias. There are 3 types of biases. Okay, we got the base current bias or fixed bias, the self bias, which is what I believe we got over here, and a combination bias. A combination bias is where you take a fixed bias, and what's fixed is this over here, because we got a voltage divider, which is R1 and R2, and they are fixing the amount of voltage that is over here, and that only changes based on whatever the input, whatever sine wave that the input brings. And there is, to stabilize it, there is this resistor over here that improves the stability of the current flow between the emitter and the base, and therefore by accomplishing stability between these two, you are accomplishing a good stability between the emitter and the collector, which is what's going to the output. When transistors are used as amplifiers, they are used in 3 different categories, and they categorize them as class A and B, B, and C. Here I got a little signal coming in, and then here I got the after signal after the amplifying process. So if I keep this in mind, in class A transistors, when the signal comes in, well, this will be a class A because this little signal comes in, and between here and here there is 180 degrees, and between here and here there is the other 180 degrees, a total of 360 degrees. So the transistor conducts for the whole 360 degrees. That is a class A transistor. They use a lot of power, so therefore they are said that they are not very efficient, because they are conducting the whole time, but they had high fidelity. The class A and B, it is described as a transistor that conducts greater than 180 degrees, but less than 360. And that is represented by here. So it's designed that it will cut off. Cut off means it will not conduct for that part of the majority of the signal. So, actually, it will conduct for the majority of the signal, but it will cut off by one little area. So, a little bit of information is being lost over here, but it is okay for this type of transistors, depending on the application that they are used. The class B, that one conducts exactly only 180 degrees. This is the area that conducts. This is the area that does not conduct. So we are really losing pretty much half of a cycle. Here, it pretty much will look like a whole bunch of, pulsations that will be amplified. And those pulsations they get, depending on how tall they are or how short they are, they carry information. Class D, they had horrible fidelity, but they are the most efficient because they only conduct for a very short period of time of the whole signal and is in cut off most of the area. One way, or another thing, another terminology you need to keep in mind is saturation. Saturation, according to this, is whenever the transistor is biased, and then, so let's go to here. Let's say that this over here, it goes up, and this tip over here is that tip. Well, that's what we established earlier. But what happens if this is the maximum that the transistor can amplify? If this signal was a little higher over here, then when it will get to this point, there will not be any way to amplify more. So the whatever information was on top of it, the crest of it, it would be, well, cut off, because the transistor, it is said to be on saturation. It cannot give out more than what the maximum that he can give out. More information can be found in the NEET module number 7, and I suggest that you study it for test and advancement purposes. I'm not gonna cover it so much because in all of my years of experience, even though I have studied transistors and played with them and used them in different applications, as an EM, I had never really worked with amplifiers.